Well, welcome back everyone to the final automation talk with myself, Jake Hall, the manufacturing millennial, and of course, this entire series brought to you by Robotiq. We've hoped you've enjoyed the last two sessions that we have, and if you haven't been able to see those, we encourage you to go back and watch them. But today we're talking about automating your CNC and machine tending processes. And once again, I'm excited to be joined by two amazing guests with me. We have Ryan, who is the commercial VP of Robotiq, and of course, Michelle as well. He is the product owner and machine tending at Robotiq, and then myself, the manufacturing millennial. So over the past few months that you've been watching these series and weeks with us, is we talked about a lot of different ways we're solving problems in the industry and how we're driving solutions using collaborative robotics to make it easier for the machine builder and the manufacturer to integrate solutions. And it's really interesting because we just went into IMTS. So it was the IMTS a few weeks ago, just wrapped up FabTech as well. And one of the biggest things we're seeing is how we're making it so machine builders and manufacturers can automate their processes easier. And like this photo is a great representation of what we're looking at when we're seeing that common CNC manufacturer. There's a lot of different types of CNC equipment out there from different brands. And here we have a couple of collaborative robots that are doing the machine tending operation. And I think what's really exciting about this is when you look at where the industry was 5-10 years ago, a lot of times robots weren't a big part of it because we all know if you're in the CNC space is a very, important, and Ryan, you could agree with this as well. The space is a huge, asset on the floor right now where they're trying to squeeze in as many machines and pieces of equipment and testing and validation places as area. And a lot of times when you do traditional automation, it took up a lot more space. And when you look at here, this is what we see at a lot of times in the CNC areas. There's pretty much no room, to walk in here. And I think that's why a lot of us who are on this call today and you're here and you're listening, you say, okay, this is very familiar with me. I'm working in a limited space, limited working area. What's the best way to run an automated process? And so,
Exactly.
Ryan, what else do you have to add to that?
Yeah, I mean, I think, as you said, people are turning to robotics to automate these manual processes, right? So you look at machining as a classic case where, you have usually a couple of different things going into the machining process. You have a machinist who's setting up the machine, they're doing work that's going to be getting everything running, and then you have the process of keeping the machine running itself, right? And for a machine shop or a captive shop within a larger manufacturer, or even a job shop, keeping those machines running is critical to you bringing value to the company, right? It's effectively you're not making money if those machines aren't running.
Yeah.
But finding people that there's a lot of reasons why that manual process of tending machines today is just not viable to continue. And in our minds, it doesn't really make a lot of sense anymore in this era to have people just doing the simple job of putting a part in, pushing a button, and waiting for something to happen. So that's why we're hearing from more and more folks, hey, we want to automate with robots. We see this as a way to go forward, but the not all robots and not all ways to automate CNCs are created equal, right?
Yeah, absolutely. And I think when we look at this, and feel free to jump to the next slide. When we look at these automation processes, a lot of times it's one of those things where we're doing it for multiple reasons. One is it's because there is a labor shortage. We simply can't find the people to program the machines, or the people to operate them, or we're running multiple shifts. We just simply can't find enough people to do those machines. And I think as things are becoming more competitive in this industry and we see more reshoring happening, companies are having now the opportunity to make and manufacture stuff that's they didn't have the chance before. And a lot of times when we're doing like what we're seeing here, when we're doing that manual machine tending, time, worker only has a certain amount of time to manage during the day, human potential where people are better assigned to better value tasks. If an operator is just standing there, as we all know, just pushing a start button, waiting for that machine operation and do subtractive manufacturing on that, and then once that machine's done, grab that part, open up the door, grab that part, put a new part in, close the door, and push a button, and that's all that person's doing, there's a lot more value that can be driven from them. And on top of that as well is that human potential a lot of times doesn't have the ability for them to be working at a night shift or on a weekend. You simply just can't employ them. And I think that's one of the biggest values that we're seeing from machine tending is running as not even this always a complete lights out operation, but what is really interesting, I was actually talking to a medical device CNC manufacturer like 3 weeks ago. I went there, did a tour. They have over 85 CNC machines on their floor, 20 collaborative robots, and they're actually installing a come to work for job setup routine. So they would come into work, they would set up the job, they would program the robot, they would get things running, and then they could take like a 2 or 3 hour break during the day, go do things, and then come back to work and then set up the next job and then leave. And so it was really interesting because it's also creating flexibility in those workers as well for people who might not be able to do a full 8 to 10 hour day. Now, all of a sudden, though, you can pull those skilled assets in that need that flexibility, but then it allows you to still have that productivity on that side. And then, of course, the ergonomics of it as well. Anytime we're reducing the need for human workers to pick up heavy parts or move sharp objects around, there's that safety aspect as well.
Yeah, we know from the demographics that those problems aren't getting any easier, right? I think that when we talk about getting younger folks into manufacturing, they don't want to just be standing in front of a machine pushing a button. If that's the job they get hired for, they probably aren't going to stick around for too long, right? They want to be contributing, they want to have flexibility, all those things we talked about. And getting involved with robotics certainly is one way to keep them engaged in their job. But again, as I said, when we talk about automating with robots, we can mean a lot of different things, right? And the reality for a custom robot installation to automate CNCs, if you got a super, super high volume process, right, with a machine that's running 24/7, nothing's ever changed on it, you don't need any human access or interfacing. Well, this is what you see on the screen right now is what it's probably going to look like. But as Jake, you said earlier, floor space is not abundant in a lot of these shops that we're talking to. So putting something like this in is not actually particularly feasible for a lot of them, right? So space, those kinds of things are not available for everybody. The amount of changeover time involved, if you do need to change over when it's all custom integrated, could take an awful lot more involvement there. Expertise to actually deploy a custom system is usually something that a machine builder and integrator is going to have, and ultimately you're going to pay for that expertise, and you have to have a process that's really going to justify that if you want that kind of custom hard traditional integration that you kind of see on the screen right here.
And I think a lot of it as well is a lot of your assets and equipment on the floor, range and when they were made as well. You could have a CNC machine that's a brand new Haas, and you could also have another CNC piece of equipment that's 40, 50 years old that still runs true, it runs great, but how you would integrate to those systems is completely different, where a lot of times, you'd have to completely open up a panel and basically do surgery to get that machine talking to a machine tending or a robot cell or a PLC.
Yeah, and it's a preview of some of what I'm going to talk about now. So I've been working, for over the last decade with different machine shops, and as I said, in all kinds of different capacities, contract shops and different shops that are within other manufacturers. And these are some of the things that I've seen when talking to them, that they've been really, let's say, excited about automating with robotics, but these are some things that have held them back. And that's what we're going to talk about in a little bit, kind of our plan to get around some of those challenges and make it easier for folks to automate with robotics. And so, one of the things that, hopefully you can see now on the screen here, is that very often the shop floor, we'll go walk out with a manufacturer, and the shop floor, it's like somebody just sprinkled a whole bunch of different brands all over the floor, right? Different operations folks bought different machines for different purposes at different times. As you said, Jake, you got perfectly fantastic Swiss machines that have been running for 45 years in one corner of the machine, but then you got some other brand new machines with different brands on other part, and you want to automate a whole bunch of different ones, but you want scalability. You don't want to have to reinvent the wheel for every single machine. But the reality is, with a lot of the current technology, that's what you have to do. Communicating with every one of those machines is going to be a totally different can of worms. And so that limits your scalability dramatically. Another thing that we see, as you already alluded to, Jake, is the age of the machine will oftentimes limit the available options. So the traditional way to automate a CNC machine center is to get a robot, connect it via some kind of communication protocol to the machine. For a lot of machines, that means wiring invasively to that control panel, unless they have a specialized communication card or something like that. For an older machine like the one I've shown on the screen right now, there's not going to be any communication cards available, right? So you're talking about wiring into relays and really getting in there. And boy, that machine's been running for 40 years. Do you really want to go in there and start?
Careful what you're poking inside that control box.
Exactly. So that's been another major challenge where, as we have here, it's not going to be worth the headache for you oftentimes to try to automate that with a lot of today's technologies. And then the third, example here is, you've done some research and you found, hey, I do have a communication card for my machine. It's a little newer, but then you find, oh, darn, it's $10,000 and it's got a 12-week lead time. And then I got to pay somebody on top of that to come in and factory install the communication card, just so I can then talk to the robot when I buy it and install it, right? So you're talking about, it should be simple, right? That's kind of our mantra here. And the alternative is you want to get into the control panel and you get alligator clips and you connect stuff up to the PC board, right? But I don't know about how many of you in the audience want to be doing that to your machine that's still under warranty, right? Or that's producing you money every day. And so kind of the way we see it at Robotiq here, right, is that robots should simplify things, not make them more complicated. And unfortunately, what I was showing you there is oftentimes how it seems like it should be simple, but it does get quite complex. And so what I'm going to invite, what I'll talk about now is kind of our vision, our plan for automating machines, leveraging our years of experience of seeing how this is done, how we can make this simpler for you. So what does that next era of cobot CNC automation look like? If I were to paint a beautiful picture of the future where we solve those problems, well, the first thing we solve is we make it work with any brand so that you don't have to reinvent the wheel. You can take your learnings from the Mazak machine and apply it to the Okuma machine, right? Regardless of that brand, it's going to work. Second thing that it would do is it's going to work with new machines and old machines just the same. We don't care if it's a 40-year-old machine, it's going to work with that one the same way it works with the brand new machine. The third thing is that, go ahead, Jake.
That's a great point, right? Because you're probably not having the same machine on the floor, but if you were able to take that same approach when it comes to the integration of adding robots to the floor, and it was able to have that same base of recipe, that reduces a lot of risk when you want to then say, I want to add a robot. That robot's acting the same way from machine to machine to machine, regardless of what brand it could be.
Yeah, when you talk about folks coming in just to set things up in the morning, getting them running, you don't want a different recipe for every single machine, right? You want it to be fairly common and standardized, especially if you have more than 2 or 3 machines on the floor, which I'm guessing a lot of you do, right? So, and then that third thing, as I showed you, we don't want to be in there with alligator clips and wires connecting into our PC boards. We don't want science projects trying to interface to a CNC machine. Another thing I'm sure that we would love to have is making sure we have easy manual access. We don't want it to be like that caged, guarded, custom cell, because odds are your process is a lot more high mix, low volume than that would be justifiable, right? So you need people to be able to get into that work cell. And the last thing is that we want that deployment to be fast. We want to be up and running in a day or two, and we want to be able to make sure that we are changing over from part to part in a matter of minutes. We're not talking about hours, right? So we can do those high mix, low volume type tasks. So what we think anyway at Robotiq is that what we've come up with for a machine tending solution helps address a lot of those problems. Those are the problems we heard from our customers, and these are the things that we factored into the solution. And so what I'd like to do is invite Michelle to speak about what that looks like and how we accomplish that. So go ahead.
Thanks, Ryan. So yeah, to answer the question is how does the, I guess we took the operator's approach. So we question ourselves, how does the operator interact with the machine? So he's picking parts, he's opening the door of the CNC, he's loading the chuck or device, closing the door back, starting the CNC machine, waiting that the machine stack light change so he knows what's the status of the machine, cleaning the part, removing the chip, the coolant, and everything like that. And if it's a late, he's closing the chuck with a foot pedal. So we took the same approach with our solution. So there you go. So, you know, instead of using an operator, we're using the robot to pick the part. We're going to be opening and closing the door of the CNC with the robot itself. We're going to start back the machine by pushing on the start button or the cycle start with a pneumatic activator button activators. We're going to be looking at the stack light. Instead of using the eyes operator, we're using stack light sensors. We also have put some air nozzle on either the bracket or the grippers itself to clean the part or the chuck. And we replicated the push on the foot pedal with the foot switch activators that is pneumatically activated. So all those things is, you know, if you look at the current situation, on top of the robot that's going to move around, the grippers that's going to, you know, grab the parts, the solution includes a robot pedestal, a set of specific fingertips that, you know, we are pretty sure to cover a wide range of different part geometry and weight. Like I was saying, cleaning device as well. We do have a communication module, which is the stack light detectors. Everything comes packaged with the pneumatically, the pneumatic device and pneumatic panel and the controller itself. And of course, if it's a late machine, there's going to be a you know, how do we open the work holding operation is by pushing on the foot switch. So that's the whole thing, part of the solution.
So basically, you're taking the light indication from that stack light, and let's say when it has that part complete, it goes from like green to yellow. Now that yellow light's on, now the robot, by seeing that light turn on, says, okay, I'm going to keep moving with that operation. It opens the door, takes the part out, puts the part back in, closes the door, and then will physically push that push pedal down to say, hey, I just did what a human would do. And then that would don't go from green, then yellow down to green, and then run that operation.
Totally, that's it, Jake. You totally understand. And if you look at the, you know, when you want to deploy a robot cell, there's 3 phases. There's a design phase. So in the design phase, part of our solution, if you just want to switch the slide. So, you know, one of the pain that we heard was that, like you guys were saying, is that there's a lot of brands in the shop floor. There's a lot of different brands, different communication protocol. The recipe is really hard to have a standard recipe that fits all machine. So what we aim at is to be able to automate the thing, communicate with the machine without doing any modification, opening panel, and so on. So that brings the concept to the non-invasive solution for the machine. Just switch the slides. It's a little bit slower. So before going forward and okay, well, I need to automate. Since there's a lot of I guess a challenge in machine tending with robot and CNC is the variables like communication protocol, difference of machine milling lathe. So we created a fit tool that's going to help the customer to choose a proper setup for their own machine. So am I trying to automate a milling machine or a lathe? It's going to be quite different. Does I plan to have my part presented to the CNC or the robot in a structured way, or it's going to be unstructured? How do I start the machine by pushing on a button? Do I have a nodal door? So just by clicking on those couple of options on the fit tool, it's going to build the suggested package of solution to fit your own specific machine.
That tool's right on the web, and it's something that folks can use today to just get a confirmation of not only is the machine tending solution a good fit for your machine, but what specific configuration is the right fit, for example.
Exactly, and it's also giving you like a grocery list of what will be included as well. So in the integrate portion, so you choose the solution, you're ready, the robot's there, you know, you open all the boxes and you're ready to go. So in the integrate phase, we try to simplify the installation as well to make it sure that it's CNCs are printing money machine, I guess, with chips and coolant though, but we want them to run as quick as possible. So in the integration phase, the non-invasive way I was talking about is you're not opening any panels. You don't have to have the electrical wires and everything like that. So it's really easy to install. You just put that on, the monitor, the machine status with the stack light detectors. It's fully easy to install. Same for the foot switch activators and also the press button. There's no wires into the machine as well, so it's really simple to install and quick as well. So we're saving time on the installation.
And it looks like with this as well, with that push button and the brake pad, a human can still push the button and do the foot pedal as well. So it's not like you're completely removing that from the operation. If they need to press the button, they can still press the button.
Definitely. You know, in the changeover time in the high mix, low volume, people will have to introduce new CNC program and do some setup time. So we don't want to be removing everything in between. We want them to be efficient. So that's why everything that you see there, like you were mentioning, the button activators and the foot switch, you could press it and operate it manually without having to remove that. Mm-hmm. And on the other side, the other thing is once you install the whole hardware, I would say, the communication module and everything, now it's time to program the robot. So one of the feedback we had from people that did automate is that, yeah, the UR robot is really simple to automate, but if I'm not from the automation industry, where do I start with? How do I do and save some time in the programming of it? I guess it's that's exactly what we try to solve with our machine tending copilot. So you go on what you see on the video right now is the teach panel of the robot. So you're going to choose the parameter. Is it the milling? Is it the lathe? Am I using a single gripper or a dual gripper? And after that, you're going to automatically generate the proper program structure based on your CNC and your current situation. So you don't have to start from scratch and think and then do all the engineering of thinking about how to be efficient in programming. We took care of you on that side. The other thing is once you're going to have. Oh, sorry, Ryan.
Sorry, Michelle. I was just going to say that I think something that's important to note is that a robot, in this case, a universal robot arm, it's a general purpose tool, right? It's a robot that can do anything. That's just an arm, right? And the programming interface is designed to be general purpose to you can teach it to do all kinds of different things, right? But by having the machine tending copilot, which is very specific to the process of machine tending, CNCs, it's going to get you there a lot faster than if you use that general purpose UR application environment versus the machine tending copilot.
Totally true. Yeah. And then the other thing where if you switch the slide, we're going to see a little bit other things. So on top of all the program and all the steps have been think, and you don't have to think about how to do the program. Then we created some interface where it speaks to the machinists of this world that haven't been programming robots since 20 years. So we took a big image and simplify with all terminology that they're going to be able. So our goal was to you don't need to have a automation expertise at all to be able to automate and do a machine tending. So you're gonna see some windows like that, which is specific design for machine tending, and it's really simple and intuitive as well to fill. So yeah, so on top of that, then let's say you've designed the cell, the robot is in motion. Now you fall in the operate, so the robot's going to be loading and unloading the machine. So we've got you covered as well. In the operate, if you think about that, we simplified the installation, the programming, and everything like that. So that means that we are unlocking the small batches. Okay, many times I've visited the machine shop, and they say, well, under 500 parts, to put a robot there program, I'm not going to be receiving a proper ROI, so I prefer to have a human operator to do it. Right now, that we lower the small batches. So now it's so simple to install and to introduce a new part number in terms of programming, that the ROI is even good for small batches. So that's really.
And we've done that time test, right, Michel? And it's, you're
Yes.
talking about 10 minutes or so compared to, an hour more with the traditional, even with a cobot with UR, the traditional programming way, without that specialized machine tending copilot. It's a big difference in terms of change over time.
Yeah, exactly. So quick example before we head up is that those are actual customers that did master their process. They did automate. You've seen the first pictures. I guess it's from the beginning of the slide. It's one of our customers. They started, with one CNC, one robot. They mastered the beast, I guess, to automate the first cell, and then they deployed. They have over 10 robot tending machine. On this case, you see, one robot tending 2 machine, and there's the operator that is in charge of multiple machine, and his job, probably the same principle that you were mentioning, Jake. Have one operator that has split shift that manage the cell to be running all the time, and that guy now is programming the robot as well on top of this task. The other next slide, we've got a quick videos. That's actually one of our first customers of the solution, the machine tending solution. Basically, they did automate one of their CNC, and this is a CNC with the tombstone and pallet changer. So they really streamlined the changeover and get a real good ROI, and they're using it since a year and a half now. And last video, I guess that's the brand new. We took it last week, actually. That's one of our another latest deployment of our machine tending solution. It's actually a double turret lathe. This is actually a contract shop that is manufacturing high precision parts. And you're going to see, probably not in this video, but the robot was loading and taking the part from one side, and then also loading the other turret as well by going and grabbing a new part as well. So they did automate it in a day.
Yeah, I think that video is from the initial startup, right? They're doing some things manually still, but that was because it was in the process of loading its very first parts before it started its production run.
Actually, it's the customer that was so happy that they sent us the video. So that's why it's also during the install, and everybody was filming everybody with the robot, and that was their first robot as well.
And that's exciting, right? If the customer is able to do that themselves and they're excited about them, they're saying, hey, I can do this. That's the goal, right? You don't need to have a special team to come out there to help you with it. You guys can, the teams can manage these installations and learn along the way, which at the end of the day, it reduces their risk, because if they know how the process works up front, if something needs to change down the road and they need to add a different program or change a different program, it's flexible for them to do it immediately. They don't have to say, hey, come out and change your machine to do a different process.
Yeah, one of the points, Jake, just before we end up, is that a lot of times, if the customer don't have the capability or the capacity because they're struggling with work and so on, they could use external expertise to install. But one of the things to keep in mind is that as you go forward, in the high mix, low volume, at some point you're going to need to introduce a new part number, and that expertise resources might not be there. So that's why, I saw a lot of deployment where there's initial with an expert on site, and then they learn how to do it, and after that they master the process.
Absolutely.
So just to sum up, I guess, I think it's the big takeaways are, as we talked about a non-invasive process at the beginning, we looked about the fact that having to wire into your machine, not only does that give me goosebumps in terms of thinking about short circuiting something on a $500,000 machine. Of course, it means you might have to outsource that process. It might end up costing a lot of money. And again, you have to do it differently for any different kind of machine based on the brand or the age. We don't have to deal with that with the machine tending solution. It's going to work on any machine regardless of the age and any brands, because of the fact that it's just interfacing with the machine just like the operator does today. It's pushing buttons, stepping on foot pedals, it's opening doors, it's looking at stack lights, and the machine tending copilot is going to bring you a much faster deployment and change over time, because it specializes a general purpose robot to do very specific machine tending tasks. And then the last thing is that, of course, because of the fact that we aren't making any permanent modifications to the machine, and we've got pass-throughs for those push buttons and those foot switches, you can go back and forth between manual setup and automated production runs with nothing in between, right? Everything is going to work the exact same one way or the other. So those are kind of the notes. And again, I would encourage anybody out there who's saying, hey, is this a potential fit for me, to check out the machine tending fit tool. If you go to robotiq.com, click on machine tending, you'll find the machine tending fit tool. It's just a couple of different buttons you can click to choose the way your machine is set up, and we can give you an example of what that would look like for the machine tending solution.
And I think what's good to remember is a lot of these small mid-size CNC manufacturers, their jobs continuously change, their runs continuously change. And when you're doing a non-invasive solution, the one thing you can do is, I need to run a machine XYZ, and I need to run this machine for the next 6 weeks because I got production here. Well, all of a sudden your job changes where you might not be running on that machine. You might want to automate a different machine that has a different process or a different type of mill where machine A couldn't complete that task, the machine B could. Now you can, through a non-invasive way, pick up that equipment, move it over to a different machine, take off that push button, take off that foot pedal, take off those stack light indicators, and move them around and have that flexibility where if you wanted to automate a machine, you don't need to go in there and buy a specific communication card to make that happen. You could say, I'm going to run on this portion, and then depending on where my next highest rate job is going to be in the future, move to a different machine, and so on and so forth, and have that flexibility from a really an ROI perspective. Is you can then justify, hey, I'm not investing this for one specific machine. I'm investing on this for varying machines depending on where my productivity is during those weeks of production.
Exactly. So scaling those learnings is a lot easier.
Absolutely. Well, once again, we would like to thank you for joining us for our final automation talks. Man, it's been a lot of fun talking about all these different industries, from end-of-line palletizing to the food and bev industry and the pharma industry, and today talking about machine tending. And then hopefully in the near future, going into 2023, we're going to have another series of automation talks as well. Of course, if you have any questions, we're going to have more information available for you if you want to see the videos or this presentation or the links, or if you have questions to anyone here on the part of this call, we would love to answer them for you. But until then, Ryan, once again, thank you for joining us. Michelle, same way, thank you for your expertise in talking about how we integrate these solutions. And until next time, we hope you have a wonderful Thanksgiving week in just a little bit. We'll see you again soon.
Thanks, everyone.
Thanks.